Classify each of these following acids as strong or weak. If acid is weak, write an acid ionization constant. Okay, so I have A, which is HF here. So HF here is, or actually, let me write down all the acids. Or actually, let me write down one by one here. HF here, and I know this is hydrofluoric acid. So hydrofluoric acid here is a strong acid. You could think of hydrofluoric acid as HCl or something like that, but even stronger. So this case here, this will dissociate fully into our water. So therefore, this here is a strong acid. B here, I have HCHO2. And this here automatically right off the bat, I know that this here is an organic acid, right? So this here is going to be, you can think of this as acetic acid, or not acetic acid. This would be methanoic acid here. Methanoic acid. Or you can think of it as formic acid here, because I only have one carbon here, right? So this here would be an organic acid. So this here is a weak acid. And it says I'm going to have to write down the the ionization constants for the weak acids, which is okay. C here is H2SO4. This here is sulfuric acid. I know sulfuric acid here is a strong acid because it dissociates fully in water. Strong acid. And finally, D here is H2CO3. This is carbonic acid. And carbonic acid here is a weak acid. And this here because it's just because it doesn't dissociate fully in water here. So this here is going to be a weak acid. So let me write down the dissociation constants for these guys here. And I'll only write it for B and C here, because these guys are the weak ones here. So I have HCHO2. CHO2. I'm going to add water to this. It's going to dissociate, obviously, into, I have my hydronium ion, and then this is going to lose an H, right? So I'm going to have it's going to be CHO2, and then the negative charge here. So this is going to be my dissociation constant, and the K for this guy here, or this is going to be the reaction here. The K here is going to equal, we have CHO2 times our hydronium ion divided by HCHO2, the concentration of this. And this will give us our K value here. So let's look at the solution here. And as you can see, this here is correct. They wrote it as HCOO minus. You can write it as HCOO minus. It doesn't really matter. I just wrote it as this because they gave us this as well. I personally like this notation a lot better, which is great. And then for D here, I have H2CO3. Add water to it. This is going to give me hydronium plus I have HCO3 minus here, which means our K value for this guy is simply the concentration of our products, which is going to be HCO3 minus and H3O plus divided by our H2CO3 here. And these guys are already balanced here, so this is perfectly fine. So this solution here is correct, but I don't like how this is negative and this is negative here. It's supposed to be H plus or H3O plus. H3O plus here. So let me just correct their solution here. But the solution is correct. Note that H minus is rewritten as either H plus or more specifically H3O plus.